Welcome students. In this video I am going to explain nitric acid. First we will discuss about preparation of nitric acid. Preparation of nitric acid. Laboratory preparation. Heating of potassium nitrate or sodium nitrate in presence of con H2SO4 to give nitric acid. Heating of potassium nitrate or sodium nitrate in presence of concentrated H2SO4 to give nitric acid. Sodium nitrate. Next, industrial preparation. This preparation takes place through Ostwald process. Ostwald process takes place in 3 steps. Step 1. Oxidation of ammonia. In presence of platinum or rhodium catalyst, 500 Kelvin temperature and 9 bar pressure to give nitric oxide. Step 2. Oxidation of nitric oxide to give nitrogen dioxide. Step 3. Hydrolysis of nitrogen dioxide to give nitric acid. Hydrolysis of nitrogen dioxide to give nitric acid. But here nitric acid concentration is 68%. 98% concentrated HNO3 can be formed by dehydration of 68% HNO3 with concentrated H2SO4. So by using concentrated H2SO4 we can prepare 98% con HNO3 from 68% HNO3. Next, properties. Nitric acid is colorless liquid and it exists in planar molecule. It is exist in gaseous state. Planar molecule is exist in gaseous state. This is 130 degrees and this one is 140.6 picometer. This bond angle is 102 degrees and distance between O and hydrogen is 96 picometers. This one is important for commutative. And HNO3 acts as strong oxidizing and strong acid. HNO3 acts as strong oxidizing agent and also acts as strong inorganic acid. HNO3 is also one of the strong inorganic acid as well as it acts as a strong oxidizing agent. All metal atoms can oxidize by HNO3 except gold and platinum. Platinum and gold cannot react and are not dissolved in con HNO3. That's why these two metal atoms are called as inert metals or noble metals. Except platinum and gold. Remaining can react with HNO3. And also based on concentration of HNO3, different metals give different products. So once we will discuss here, positive reduction potential element reacts with con HNO3, gives nitrogen dioxide. Suppose positive reduction potential metal reacts with dilute HNO3, gives nitric oxide. Are you able to understand? Positive reduction potential element like copper. Suppose copper react with copper metal react with con HNO3. Copper metal react with con HNO3. Con HNO3, it gives copper nitrate NO3 twice plus nitrogen dioxide plus water. Copper metal atom suppose react with diluted HNO3. Diluted HNO3. Common copper nitrate is the common product, whether it is a dilute HNO3 or con HNO3. Copper nitrate is common product, but if dilute HNO3, it gives nitric oxide plus water. Are you able to understand, children? If copper react with con HNO3, it gives copper nitrate and nitrogen dioxide. Copper react with dilute HNO3, it gives nitric oxide. Copper nitrate is common whether it is con HNO3 or dilute HNO3. Copper nitrate and water are common, but con HNO3 it gives nitrogen dioxide gas. If dilute HNO3 it gives nitric oxide. Okay, we may have to balance also. Suppose con HNO3, only 1 mole of copper is combined with 4 moles of HNO3. It gives 1 mole of copper nitrate and 2 moles of nitrogen dioxide and 2 moles of H2O. Suppose dilute HNO3, 3 moles of copper is combined with double the amount, 8 moles of diluted HNO3 and 3 moles of copper nitrate and 2 moles of nitric oxide. Understood, children? So positive reduction potential element like copper react with con HNO3, release corresponding nitrate and nitrogen dioxide. So if concentrate HNO3, it gives nitrogen dioxide. If dilute HNO3 is react with positive reduction potential, gives nitric oxide. What is this? Nitric oxide. Nitric oxide. We'll take next one. Suppose negative reduction potential element. Negative reduction potential element. Negative reduction potential element like zinc. Suppose zinc react with con HNO3. Con HNO3 gives nitrogen dioxide. Corresponding nitrate, zinc nitrate, ZnNO3 twice zinc nitrate, and gives nitrogen dioxide plus water. This one is common. And zinc suppose react with diluted HNO3, ZnNO3 twice is common, but here it gives nitrous oxide, N2O. It gives nitrous oxide, laughing gas, nitrous oxide plus water. Understood? Negative reduction potential element like zinc react with con HNO3, gives zinc nitrate and nitrogen dioxide and water. If negative reduction potential element like zinc is react with dilute HNO3, gives zinc nitrate and nitrous oxide and H2O. So we have to balance. Suppose dilute concentrate HNO3, just you take 4, same like copper only. Zinc combined with 4 mole of HNO3, it gives zinc nitrate and 2 moles of H2, 2 moles of NO2 and 2 moles of H2O. And dilute HNO3 combined with 10 moles of dilute HNO3 and gives zinc nitrate and 4 moles of nitrous oxide and H2O. And next one, chromium and aluminum do not react with chromium and aluminium do not dissolve in ConHNO3. Chromium and aluminium do not dissolve or not react, dissolve in ConHNO3 due to formation of passive or oxide, passive film of oxide layer, passive film of oxide layer on the surface of metal, Chromium and aluminium, amphoteric metals. Chromium and aluminium do not dissolve in the ConHNO3. What happens, children? Here passive film oxide layer is developed. Suppose chromium is combined with HNO3, what happen? On the chromium surface, one oxide film layer is exist. Oxide layer of the chromium is developed on the chromium, that is protects the chromium metal atom. Are you able to understand? Chromium and aluminium do not dissolve in the ConHNO3 due to formation of passive film of oxide layer. If you are store HNO3 in a chromium container, what happens? Inside the walls, one oxide layer is developed, that is protect the chromium from the HNO3. Okay, understood? And ConHNO3 can oxidize non-metal atoms also. ConHNO3 can oxidize non-metal atoms. Like iodine, carbon, sulfur to give corresponding, phosphorus also to give corresponding oxo acids. For example, iodine is combined with HNO3, 10 moles of HNO3, 1 mole of iodine to give corresponding oxo acid, iodoic acid, periodic acid, HiO3. And nitrogen dioxide is common, NO2 plus 4H2O. And suppose carbon reacted with HNO3, corresponding oxo acid, carbonic acid, but carbonic acid is ready to give CO2. So C is converted into CO2 and nitric acid, from the nitric acid release NO2 gas and water molecule. So 2H2O and 4NO2. So here 4 moles of HNO3, not 10 moles. Next, sulfur. Sulfur atomicity is 8. Sulfur is exist in 8 atoms of sulfur in the atmosphere. So sulfur is reactive with HNO3. It gives H2 corresponding oxo acid. Sulfur oxo acid is sulfuric acid. So H2SO4 plus nitrogen dioxide plus water. Nitrogen dioxide and water are the common. But if the element change, it gives corresponding oxo acid. Suppose take P4. P4 react with concentrated nitric acid. It gives phosphoric acid. H3PO4. Phosphoric acid plus nitrogen dioxide plus 4H2O. Understood? So non-metal atoms also can oxidize with ConHNO3 to give corresponding oxo acids. Iodine react with ConHNO3 give periodic acid. Carbon react with HNO3 gives carbon dioxide and nitrogen dioxide. Sulfur oxidize with HNO3 to give sulfuric acid and nitrogen dioxide. Phosphorus oxidize with HNO3 to give phosphoric acid and nitrogen dioxide. Next one, how can you identify nitrate ion? That is brown ring test. Identification of nitrate. Brown ring test. By brown ring test, we can observe nitrate ion. So for this, first you have to take salt solution in dry test tube. Nitrate salt solution. Nitrate contained salt solution taken in a dry test tube. And add freshly prepared FeSO4 solution and add ConH2SO4 corn H2SO4 along the sides of the test tube. Add corn H2SO4 along the sides of the H2SO4. Then this is FeSO4 solution. In between these solution you can observe one brown ring. This is called as brown ring test. How can you did this brown ring test? First you have to take salt solution in the dry test tube and add freshly prepared FeSO4 solution and keep the test tube in the inclined position and add corn H2SO4 along the sides of the test tube. Then you can observe brown ring formation between these two solutions. So then it indicates presence of nitrate. Understood? So what happened? First, nitrate is combined with iron 2 plus in presence of acidic medium gives nitric oxide plus iron 3 plus water. Understood? Nitric oxide. Now this one is combined with freshly prepared FeSO4 solution already we added. In that FeH2O 6 times this complex can exist. This complex reacts with nitric oxide to give FeH2O 5 times NO2 plus. Due to formation of this complex, it exhibits brown ring. Are you able to understand? When FeH2O 6 times is combined with freshly prepared FeSO4 solution is there. In the freshly prepared FeSO4 aqueous solution contains this complex. This complex is combined with nitric oxide to give FeH2O 5 times NO. It is called as brown ring. So what is the formula of brown ring? FeH2O 5 times NO. And oxidation state of NO here +1. What is the oxidation state of NO here? +1. So this one is very, very important. Not only CBSE, commutative also. This one is very important. They will ask question based on equation. So these two equations are very, very important. Thank you.